So um, first of all, I'm going to go into how you're building the smart contract. I prepared a few slides. So here, the first Solana program, Anchor contract, and Astro UI. So as I said, it will persist of the Anchor smart contract and the Astro UI. And at the end, I will also send you the link to the finished website that we're going to build, and you can enjoy blogging. All right, so first of all, what is Anchor? Well, TLDR, it's a framework for building smart contracts, and it makes it much easier than writing native contracts natively with C++ or C, because it provides a lot of tools to simplify the process all over. And for the front end, we're using Astro, which is actually just another JavaScript framework, which I found pretty interesting. And the special thing about Astro is that it uses this thing called dynamic islands, which minimizes the amount of JavaScript in your application. And of course, server-side rendering, it's a multi-page application framework, and you can use any framework components that you like. So if you're a React person, you can use React components. If you're a Vue person, you can use Vue components. And the way this whole thing works is that you have your Astro website here, and you can have different components without any interactivity at all, and those components won't have any JavaScript, which means that if you have, for example, a static content page, then this static content would be an Astro component with 0 JavaScript. And if you had, for example, an image carousel, which is of course interactive, you would create a framework component with, for example, React, and only that specific component gets JavaScript. So you're really saving up a lot of, well, resources. All right, so let's hop into the contract. For that, we can create a new Anchor workspace. So you do that by typing Anchor, new, and then the name of the workspace. Well, let me go to another directory. And then you can type Anchor new and then block in our case. And well, no, wrong, sorry. Anchor init first, because this initializes a workspace. And we define DevNet as the cluster. And now it creates a Anchor workspace for us. If you need to install the Anchor CLI, Solana CLI, and all that first, check out the recipe. I linked the instructions on the official websites. So then let's open this in VS Code. So like this. And there we go. Here's our Anchor workspace. We've got this blog directory, which is the name of the workspace, programs, where our main program will be or already is, and our tests, and the rest you can ignore for now. We also got the anchor.toml and cargo.toml. Those are just configurations, and yeah. So the first thing we're going to do is that we're going to create a clean folder structure. The normal way to do it in Anchor is that we have this a file called we have the lib.rs that's already here, which is our main file. And right now we only have the boilerplate code in here. So other than that, there's the states file. So states, states.rust. Then we got a constants file. a errors file, and really important, the instructions folder with one file for all our instructions and a file to export all the other files, so that we can import, we don't have to import each file in the instructions directory, but instead we can just import all the files inside of the instructions directory at once by exporting them in this mod.rust file. All right, so the first thing we want to do is write the boilerplate code in the lib.rust file. And for that, we got this pub mod block thing, which is basically like our main function. And this is annotated with this hashtag program thing, which is also anchor boilerplate. We're going to remove this here. And now, since initialize is not a function in our contract, we are also going to remove this. And yeah, so our really first function for our block is going to be the init user profile function. So init user profile.rust, because our block will consist of two major states. We will have the user profile and the post state, and every person who wants to create a blog post has to first create a user profile. Exactly. So for that, we will first go to the mod file, and we are going to export it. Pub mod init user profile like this, and we will import it in our lib file.
Just a quick question: is that pub mod? That mod keyword is what exports things, right? Or how do you what's the export in that's going on to there?
The pub mod, I think it should be mod. Yeah, I think it's mod. No, sorry, no, it's not mod, it's pub. Sorry, pub stands for public, and mod is just kind of the module. I think it's what it stands for.
Okay, so it's not like in JavaScript where you have to export whatever. It's just pub, and then you can reach it.
In JavaScript, this would have probably been export and then I don't know, const init user profile or something like this.
But in Rust,
in this case, we have pub,
and you can reach it.
Exactly, pub, which stands for public.
Okay, cool.
So exactly. In the init user profile, now anchor instructions always have a really similar pattern. It's basically always the same. We have the so-called struct. So let me import the relevant things first. So we got the so-called struct, and in the struct we define all the things we need for our instruction. So our struct is going to be called init user profile, because we want to initialize a user profile first. For that, we want an account user profile like this. Then we have the authority. Sorry, not let, it's pub. And we have the authority, which is the signer of our transaction, and the system program here, which is needed in every instruction for the smart contract to handle things. So now we got things that we haven't defined yet. So the user profile, for example, and for that we're going to the states file first, and we're going to define the user profile. So the user profile is an account, or it's basically a state for an account. And what an account even is, I will go into that in a moment. But first, so the user profile consists of an authority, a Twitter handle, and a created posts count. So the authority is basically the wallet that created the user profile. The Twitter handle is self-explanatory, I think, and the created post count is just a counter that goes up every time you add a new post. And yeah, so what is an account though? So an account, we can imagine the Solana blockchain as a big collection of documents, and every account is a document with its own data. So we have the user profile document in this case, which has the user profile data, authority, Twitter handle, and create post count. So maybe if you're using MongoDB or something, have you ever used it? It's basically like the collections and documents scheme, very similar. All right. So now this is not complete yet. We're still missing the annotations. So to initialize the user profile, what we need is this block of code. Don't panic, I will go through all of it. So first of all, we want to initialize the account. Then the second thing we've got here are the seeds. So seeds are basically an array of identifiers to get the address of that account. So for example, if we want to find out what the address of the user profile is, we have to combine the user profile tag with the public key of the authority to get to the address of the user profile. What is the user profile tag? The user profile tag is a constant that we will add here. So like this, it's a string as a byte array, which is in Rust declared with this p. This makes the string an array of bytes. So we're going to use this and the public key of the signer as the seed for the user profile. Then next off, we got the payer equals authority. This means that the authority will be the one paying for the creation of this account, since this account contains data and data takes space, and space again is not for free. We have to pay to initialize the account because it takes space on the blockchain, and this will be done by the authority. Then space, the space, as already said, accounts take space on the blockchain, and we have to declare at the beginning when we initialize the account how much space will the account have. And there's the thing that we cannot change the space once it's initialized. So if you need more data, then you cannot increase the space of the account. And it's the same for the other way around. You cannot decrease the space if you don't need it. So from for that, I've got this max size variable in, well, I haven't got it yet, but we will create it. It's, if you can imagine structs like classes in object-oriented languages like TypeScript, and we can just add this max size property by using impl so that we can access it like that. And here we will just calculate the max size this account will or might take. So as you can see here, we got the authority, which is a pub key, the Twitter handle, which is a string, and the created post count, which is an integer with maximum of 16 bits, right? And you might ask yourself now, how am I going to know how much bytes all the types take? Don't worry about that, because the Anchor docs have a pretty nice overview of that. I will get it here. So there you go. You have the space reference, which is also on the recipe, linked on the recipe. And here you can see, for example, we got the authority, which is a pub key, and the pub key takes 32 bytes. So we're going to add 32 bytes for the authority. Then we got the Twitter handle, and with the Twitter handle is a string. So, and strings take 4 plus the length of the string in bytes. So now this means we have to limit the length of the string, because by default, a string can be infinitely long, not like the U16 type, which can have a maximum of 16 bits, but the string can be infinitely long. That's why we have to set a limit ourselves. For that, we are going to add this max Twitter length constant as well here, like this. And as far as I could find out, the maximum length for a Twitter username was 15 characters. So I chose that. And so now here we can do like 4 plus 15, which is the max length of the string for the Twitter handle. And last but not least, we got the created post count, which is a EU16, an unsigned integer. And here, this one is clear again. This one takes 2 bytes. So there's the max size variable. Now, anchor itself, it says in the documentation that you have to add 8 to the space constraint for anchors in terminal discriminator, which means that you have to add 8 on top of the max size of the user profile, which is also boilerplate. All right, so that's for the user profile. We initialize it with the following seeds of the user profile and the public key of the authority. And the authority pays for the space, and the space is 8 plus the max size of user profile. All right. Then the next one is the authority, which is just a normal signer. Mute means mutable, by the way. So when something is mutable, that means that the state can be changed and it is not a constant, similar to let and in JavaScript, where you can update let and const would be static. Let would be mutable in this case. So the system program, as I said, this is anchor boilerplate, and we just have to add this in every struct for our instructions. So now we have to call the function itself. So we got this handler. So we got this handler, and the context is basically just this anchor type or also struct with our struct that we just defined here. And we got the Twitter handle that we want to pass in later when a user creates this account. And we first, to make our code cleaner, we want to create a reference to the user profile. So for that, we just do a mutable reference, so that the end and mute stands for mutable reference to the user profile in accounts. So we're taking that, and after that we're checking, okay, is the Twitter handle length bigger than the max Twitter handle length? And if so, then it should return an error, because we won't have enough space to store a Twitter username longer than 15 bytes, because we defined that in our max size like that. So we have to add a error code, a custom error to our errors.rust, Twitter handle too long. And for that, we are defining a enum, so this error code enum, and we can just first add like a message and then the error itself. So this is what we reference in the code, and the Twitter handle is too long. The maximum length is 15 characters, is what will be shown in the error logs later when you interact with the program and you give a name which is longer than 15 characters. This is the message you will get. All right, and let's go back here. So here we return the error if the Twitter handle length is bigger than max Twitter handle length. And since we have now like this, the error case can't happen anymore, so we can just do our logic here. We first want to set the user profile authority to the public key of the authority from our struct. So I forgot to mention, you can access all the things in your struct by doing context.accounts, and then there's all the things we defined, like user profile and the authority. And with .key, we can save the public key to user profile.authority. Then we want to set the user profile.created posts count, which is 0 because the user has just been initialized and he doesn't have any posts yet. Then lastly, the Twitter handle, which is what we passed in here. And the very last thing we have to add is just this okay, which means, all right, this function is finished. Okay, so that's our first instruction. Init user profile. This is all we need for that. Now, I think we have some imports to fix first. So let's define it in the, let's import it into the lib Rust file. And let's import all our modules here, like this. So our constants, our errors, instructions, and states. And this also will be needed later, like this. And now we can define this function pub fn init user profile. Copilot already knows. Like this. And here we're just passing it down. So we got the context with the init user profile, which is what we defined here, and the Twitter handle. And we just return the instruction from the other file. This is way cleaner than writing all of our instructions in the lib.rust file, of course. But it's better to split them up in a file for each instruction, like this. Here we are having a little error with our imports. 1 second.
Also, just to hop in here real quick, the Zoom has been extended, so we're good on time.
Okay, great, awesome. Yeah, here we forgot to add the imports. Okay. Now, the next thing we're going to add is the create post instruction. So we're going to do the same thing, create another file, create post.rust, like this. And again, we're just first of all importing the stuff and then also exporting it. So pub mod and then create post, pub use. So that's the first thing. Now we can again define our struct for the instruction. And in this case, oh, Copilot's too fast. In this case, we call our struct create post because that's what we want to do. And we first of all need to get the user profile again in this instruction because we need the user profile to do one thing, and that's updating the created posts count after we created the post. So we also need the user profile in this instruction. So that's the first thing we are going to do, is to edit here like this. And here we don't have to add this initialize keyword like in the init user profile function, because we already initialized it, or it already has to be initialized. And also we don't add the payer or the space properties, because the space has already been set and the account has already been paid for. So what we're instead doing is we're saying mutable, because we want to update the account, since we want to update the created posts count. And we're again here having a few seeds. So the user profile tag and the authorities public key. This is what we later have to pass in to get the address of the user profile account, to fetch data and so on as well. Then the next thing is that we want to create a state for the posts. So similar to the user profile, just a post struct like this. And what we got here, an authority, again, the same. This can also be used to find the user profile of the post by checking for the authorities. So this is basically a relation between both of those structs. Then we got a title, content of the blog post, and the count. I'll go into that in a little bit. And likes count, so that we can also like each other's posts, plus this created at, which is just a Unix timestamp, so that we also know when this post was created. Then the first thing we're going to do is also create the max size for this struct, which looks like this. So here we got the authority, which is 32 bytes again. We can check from here. We got the pub key, which is 32 bytes. We got a title, which is a string, and a string is always 4 plus the length of string in bytes. Then we got the 4 plus the max content length again, a U16, 2 of them. So this makes 2 bytes each, and I64, which makes 8 bytes. And we also have to define these first, because they aren't yet, in the constants as well. So we're going into this constants file and putting this here. So the max title length is going to be 32 characters, and the max content length is going to be 3000 characters. Since this is going to be a lot higher, because we want people to be able to do bigger contents, bigger texts. Yeah, so this is it for the post struct, for the state. Then we're going into the instruction again, create post. And now we want to initialize a post. And for that, we're going to do it similar to how we did it in the init user profile function. So first of all, we're going to add this init keyword to initialize it. Then we got the seeds, and the seeds, and again, the seeds are basically an array of identifiers to find out the address of the post. You will understand that better once we are looking at the tests for the program. So this consists of the post tag, then the user profile dot created posts count, and the authorities public key. So the reason why we don't just do this, so the post tag plus the authorities public key, like we did for the users profile, is because every user can just have one profile, which means this is no problem. But when we want to create posts, we want to probably create more than one. At some point, we'll have more than one post. And if the first post has the seed of post tag plus authority, and the second one also has the same seed, this means that this is not possible. So we need to have different seeds for every account. We cannot have the same address twice on the blockchain, just as your wallet address of your Phantom wallet just exists once. Just like that, we need to have a unique seed right here. And this is why we have to add this count. And this created posts count is basically this, what we defined here in the user profile, the created posts count. And it starts at 0. And each time we create a post, we will update it by 1. So the first post will have the seed post tag 0 pub key. And then the second one will have post tag 1 pub key. The third one will have post tag 2 and pub key, and so on, so that every post that we create has a different seed. And yeah, this is similar to how you would just add a ID to your things on Web 2. If you have a document in a database, then you're probably going to add an ID for the document. But since we're on chain here, we can't use libraries like UUID to generate IDs like that. And due to that reason, I'm using a simple counter here that just increments every time we create a new post. So then again, we have the authority as the payer, and the space is, as I explained earlier, 8 plus, and then the max size. Then the next thing, again, boilerplate, the authority and the system program. The authority is also the signer, and yeah. So now we want to create the handler for the method. And here we're passing in the create post context, the title of the block, and the content. So then first we want to create these mutable references again. So a mutable reference to user profile and a mutable reference to the post from the struct. And then we're going to do some if checks again. If the title.length is bigger than max title length, it should return an error that the title is too long. And if the content length is bigger than max content length, it should return an error that the content is too long. And we first have to add these errors to our errors.rust now. So let me copy this over quickly, like this. So the title is too long, the maximum length is 32 characters, and the content is too long, the maximum length is 3000 characters. Just like this. And now you'll see, here we go. So the next thing is that we now actually want to set the post. So the data of the post. So we're going to do post.authority is the contexts accounts authority.key. So we're using this, the signer's key. Then the next thing, the title is going to be the title that was passed in here. So what we passed in the handler will be set. Then same thing for the content, and we're also sure that we have enough space because we already if checked that the max content length is that our content is not bigger than the max content length. Then also the post count. So we're setting the count at which the post was created, also in the post state, so that we know which what's the identifier of the post is basically. Then the likes count, we're setting that to 0 because we don't have any likes yet. And the created at is just a Unix timestamp And the last thing is that we have to update the created posts count so that the next time we create a post, the user profile created post count will be one bigger, and the seed will differ from last time. Exactly. And also we should define the post tag variable because we haven't done that yet. This is just the same as we have here. So like this. And there we go, the error is gone. And yeah, there's one thing missing. That's why we have an error. And that's the, okay. So everything is finished. It was successful and so on. So now we can also import that into our live.rust function like this. We're having a little error, I think due to some imports maybe. Yeah, we'll look into that later. The next function is the like post function. So when people want to like a blog post, typo. And for that, we don't need any new states. So those states that we have, these two, they're all we need. So the post and user profile state are all the states we got. Then the like post, exactly, we have to do the same thing as the last two times. We're just doing these basic imports that we need, deriving the account and defining the like post struct like this. Now, in this case, we also want the post. We want to get the post, but we don't want to initialize it. So we're going to do it like this. So we are not initializing it, but we want it as a mutable. We want it to be mutable. So we're saying that here. Then the seed, again, the same as in the create post instruction. We have the post tag, the post count, and the authority of the blog post. So this is an important difference. This time we don't want the person that signs the transaction to be in the seed, but the person who is the who made the blog post, because it might be that I don't always like my posts myself, and if that's the case, then the authority won't be the post creator because I'm the signer. So we have to also pass in the pub key of the blog post creator. So like this. And this is just an account info, and the account info contains the pub key. So again, we got the post tag, then the post count, and the blog post authority. So the next thing, again, the boilerplate, the authority, and the system program. So handler, now you might wonder, where do we get the post count from? We get that from the handler this time. So we are passing it in here in the function, and there's this cool thing that we can access that using this annotation, like instruction, and then the variable name and the type, and this will pass this variable in here, and we can access it from the struct, which is really great. So in this case, this means that the post count is like the identifier for us to find out which post should be liked. And now we're again creating a mutable reference to the post account, changing the likes count by 1, and okay, that's it. Also, we forgot to add it into our mod file. So like this. And now we should also have syntax highlighting red. Perfect. So that's it for the like post instruction. Again, we're passing in the post count not to use it in the handler, but only to access it in the like post struct to find out what the what the address of the post is. So then we got one last instruction, which is the delete post instruction. And this one will teach us another concept. So again, the imports, then we got the derive accounts, pub struct, post, and now what we want again is we're passing in the post because we want to know which post should be deleted. So we also pass it in and we do it like this. So we don't initialize it again because it already exists. Otherwise we wouldn't even have to delete it. So we're just, we want it to be mutable because we need to close the account, and for that it needs to be mutable. Then the seeds again, post tag, the post count, and the authority. We're also accessing the post count from the handler again, so we have to edit like this. Then one thing which we haven't done yet is constraints, and constraints are basically rules that make sure that your smart contract is secure. So in this case, we have the constraint that the authority of the post that was passed in is also the person that signs the transaction. So we haven't edited it yet, but here, so that's the person that signs the transaction. And we want to make sure that the post's authority is the signer, because otherwise everyone could just delete everyone else's posts, and that's of course not what we want. And also, if that's not the case, it will throw an unauthorized error. And I think we haven't edited it yet, right? So we are going to do this as well, like this. So you are not authorized to perform this action, and it's called unauthorized. And then we got this very last thing, this this close thing, and what this does is basically it closes our account with the post. So we don't so this is literally all it needs to delete an account. you just say close and then equals the person that should receive the the funds on the account. So the first time when we created the post, since we gave it some space, it cost us a few SOL, like maybe 0.00 something. And we get that back when we close the account. So we have to also give it which user should get the funds from there that are still on the account. So, and then the last thing that's missing is just the system program again for the boilerplate and the handler. And for the handler, we don't really have any code at all inside of the handler. So all it has here is just okay, and the post count parameter so that we can access it up here, because the deletion of the post is already handled inside of the struct here. So we don't have to give it anything here. That's it. And this is our last function already. Let's just add it into our into our mod file so that we can access it from the lib later. This delete first delete post. Now we can add the other ones as well. There we go. We have 4 instructions now. It looks like at some place there's a import or so missing. Let me check that. Oh, wait, this is wrong, right? We have to do it like this, sorry. This is it. So there we go. Since we want to access the create post module that we have here, create post, and then we got these handlers everywhere. So we want to use, for example, create post, and then here you can access the struct as well as the handler. And there we go. And here we have to do the same. I think we have a, yeah, right, we have the post count missing here. So we will add this as well. Post count, which is a U16, I think, right? There we go. Paste this in as well. And there we also need the post count. As I said, we need this for identifying which post should be deleted, because the post count is basically just like an ID for us. Yeah, and this is actually it. So this is the whole contract. Those are all the functions. So we first initialize the user profile, then we create a post, we like a post, and then we can delete the post again. And now what we want to do is we would like to test our application.
We got a question here of sure. Can you explain a little bit the flow of how it goes from file to file? Because in this case, you like separated everything out into like a very nice structure. Like what's the, like essentially like an instruction comes in as an entry point. How does that flow through the different files and functions? Like basically when I call here init user profile, like what's the flow that goes through the files?
Yeah. So let's say that in our front end, the user clicks on create profile. Then in the background, we would call the init user profile function. And this would be like the point where it starts executing. So this function here. And the user already gives us the context. So he provides all the things in our struct. So when he calls the function, he has to provide the user profile, he has to provide the authority and the system program. Then he also has to provide the Twitter handle, and we are just going to pass it into the handler from the init user profile module. So as you can see, we imported all the instructions here. The star basically like importing all of them from this directory here, because we have this mod file where all of them are like as modules. And so we can access all the functions inside of this file. And we got the init user profile struct as well as the handler. And in this case, we want to use the handler because we want to call the method. And we're passing in the arguments, so the context that the user gave us when calling the function, as well as the Twitter handle. And there you go. The first thing basically is you can always think as the struct going first. And well, the struct is kind of just what the user gives you. So everything that's inside of this is given to you by the user. So the user profile, the authority, and the system program is just passed in. And now we are creating a reference to the user profile that the user gave us when calling the function. So when the user pressed on create profile, in the background, there was a function called which provided us all the stuff: user profile, authority, system program. And we're just creating a mutable reference to that. After that, it just checks, okay, is the Twitter handle, does the Twitter handle have the correct size? If it doesn't, it throws the error and the instruction ends. So this stops executing here. And if it does not throw an error, we just go ahead here. The authority is set, the created post count is set, the Twitter handle is set, and once we reach OK, then we are finished. Did that clear it up, kind of?
Yeah, it cleared. Thanks.
All right, great. So yeah, this is all the code for our contract, as I said. Now let's deploy the contract using Anchor, the Anchor CLI. The first thing you see is like this declare ID thing. This is the address of our contract, but you first have to, like, this is the boilerplate address. So when you would try to deploy your contract now, it wouldn't work because you don't really own this address. So you first have to do Anchor build. Oh, we have to go into the directory first. Now Anchor build.
What happens when you run Anchor build now? I've always had trouble understanding this. Like, when do you get the address, that new generated address that you need to replace that with?
So now it creates this target folder for us, right? So the first time or every time when you don't have this target folder, it creates a new address. If it finds the target folder, it will reuse the address because the address is saved inside of this folder in one of the directories. I think it has not generated yet. Let's wait a moment. So yeah, it's basically being saved somewhere in here. When you do Anchor build the first time, when you delete the target directory, it can't find the key pair, so it has to generate a new one.
Okay. And will the Anchor build automatically replace the anchor.toml, or we need to also manually, like, it will spit out the public key, right?
Okay, the public key of the new address, or what do you mean?
Yeah. So the new program address.
Okay. Oh yeah. I will show you a trick how to find it easily, or well, it's just a command of the CLI. Once it's finished. But as you can see now, it creates all the stuff, like the build files for the contract and the IDLs. IDLs are basically JSONs with where it's just a standard for showing all the functions and variables and things that a contract consists of. I can also show you that once we're done building, but it always takes a while.
You need the
M2
Pro Mac.
Okay, so here now, as you can see, it created this deploy directory, and here we have this block key pair.json, and inside of this, my key pair is stored. I think I can show it here. It's just a normal key pair, and what you can do is Solana address dash, sorry, my German, target deploy block dot keypair.json, block keypair.json, and oh, that's the wrong command. Okay.
You were just missing an S.
Okay, address. Yeah, I think it's S. There's an S missing, right?
And then now there's an extra B.
Now we did. Right, there we go. So this is the key, the public key of our contract. Now this command is a little tiring, as we just saw. So you can just do anchor keys list, and it will list you the public key instantly. And also, if you have a workspace with multiple programs inside of this directory, you would get all the public keys listed with the title of them as well. So for here we got block and then the address. So anchor keys list. And also here the IDL, which I want to show. Sir?
I was just gonna ask a little quick question of like, if I want to have a vanity address for my program, so like I want my program, I will want this program to start with blog, whatever. Is it as simple if I just grind that key pair and I just replace the block key pair.json with that? And
sure,
so
that's also what we did for stake capital. There we got like both of our contracts start with CPTL, I think. Yeah. So you can also use vanity addresses for that. So that's no problem. You can use any key pair you like. Now, if I deleted the target directory and did anchor build again, then we would also have a new key pair. So yeah, you just have to keep in mind that every time you create a new key pair, it's also a new contract, basically. So all the data or all the accounts that were stored on the previous contract are on the previous contract.
Yep.
So then, exactly. So this is the IDL. That's what I want to show. Here we just have like it's a metadata, somewhat like a metadata for our contract. We got the version, the name, the constants that we defined, all our instructions with all the parameters and all the stuff. So this is the way how the contract is kind of expressed in as JSON. So now let's go into the tests. And what we got here is a few useless tests. And we want to make them useful. So first of all, we got this anchor.setProvider and then anchorprovider.env. And this looks at the environment, at all these files we have, these anchor.toml files and so on. And it gets a few relevant infos for us, like program ID or program.provider.public key, which is our system wallet, which we linked here. And also, of course, program.methods, so that we can call our functions or instructions. But before we do anything else, we should first update the old address to the new one. So we can just go into the VS Code search, check for that, focus the replace field, and then do like this. Then this is probably the easiest way to find all references. And also, we're currently here, it says DevNet, and well, we can use DevNet, but localnet, I mean, we can use localnet, but in this case, I will use DevNet. Like this. So we're going to write just a few tests, not that many. To simplify everything, we're first going to add a utils file and a constants file. So since this is a pretty short, tiny smart contract, we don't have a lot of util functions, so that's all. This is used to convert a number to this U16 kind of type we got in Rust. So here, but as bytes, so yeah. And also we should add these constants for the states. So the user profile tag and the post tag as buffers. So as bytes, basically. Now, oops, let's put this here. Let's go to the block.ts file again. And now describe, if you're not familiar with JavaScript tests at all, describe basically defines a group of tests, and with it you can define one test case. So basically, this is the group of all of our tests for our block contract, and it defines a new test, and we want to first initialize the user profile. So also make sure to create an async test because we need to await things. So now what we used previously with these seeds here, these seeds equals user profile tag and authority.key. So these things are called a PDA, so a program derived address. As I said, those are kind of an array of values to get to the address of our user profile. So here we got the user profile tag and the authority's public key. So we're going to do that. We're const user profile equals, and the function for that is called find program address sync. And we are passing in an array with the same things that we got here. So the user profile tag first of all, and then the authority.key, so the public key of our authority, which is program.provider.public key, and then as a buffer because it's all bytes. And lastly, just add the program ID. And this is how we find the address for the user profile. Now we got the address we want to have the user profile at, but we have not created it. So we can lock the address now if we want to, like this. Anchor test, and this will take a moment. So first it's just setting it up, everything. I think it's deploying the contract again, updating the contract. And it throws an error, probably because I don't have enough Sol right now. Yeah, so we can just do Solana airdrop. Then wait a second and now try again. And this time it should be successful. It isn't.
Not enough.
And it did even consume 2 Sol, but it still didn't work. Probably just retrying. Sometimes do be like that. Okay, now. Oh no, wait.
That's looking better.
Still
not enough Sol.
Maybe let's check again if the contract is even on the devnet right now, because 1 second here, if you go to the Solana Explorer, make sure to switch it to devnet. Look for the address, and it says our smart contract does not exist. Yeah, let's do anchor deploy first. Solana balance. Yeah, we are already down on Sol. Okay, so let's try again.
Maybe.
Sorry?
Yeah, just airdrop more. So you have like.
Okay, yeah. Yeah, you have to be careful with that because Solana really likes to give you rate limits for airdrops. Yeah. And also if you're out of airdrops, because as I said, you get rate limited really fast, you can, there's a website called solfaucet.com, and here you can also just enter your address, airdrop to Sol, and then to devnet. Right, so there are we. Now it says deploy success. If we reload now, it should be available. Right. Now this is our contract on the devnet. So as you can see, it says here, this is the address that we also got. And this is the upgrade authority, which is my CLI wallet, and so on, anchor. And here are all the interactions with our smart contract. Right now, those are just deploy and whatever, but those are not like real user interactions with the contract so far. And now let's try it with anchor test. I think it should work now. Okay, well, now it says again insufficient funds, so we have to airdrop another to solve.
So this is a thing that I've also noticed of, like, when you deploy a program and you want to upgrade it, you need like half of all the, like, how much do you need for upgrading? But it doesn't cost like extra, but you need to put it up as like an escrow, right?
Yeah, so I think there's also this thing with, okay, well, I don't think it is like that, that from the beginning on, you have a fixed space for your contract. So it gives you like some extra space from the beginning in case you're adding updates. And it's really kind of expensive actually. So it costs quite a few SOL. And I'm not quite sure how much the cost of upgrades is, because I haven't looked at it in detail when I did it for this contract. But yeah.
Okay. Yeah.
Okay, we could now lock the user profile. So the PDA, which consists of the profile tag and our public key. And as you can see, when we enter it into the Explorer, it says account does not exist, which is what we expected. So, but this is the address which the user profile will be initialized at, if everything works, of course. So now we want to call the function. So we have const transaction. Be careful of this because this is deprecated, the program.rpc. Instead, we use program.methods and then init user profile. And then we have dot accounts. And here we got all the stuff from our struct that we defined earlier. So user profile, authority, and system program are all here. Authority, user profile, and system program, like this. The system program is just a Solana contract. Well, the system program, basically. Yeah, I think the name says everything. You just have to give it the ID of the program, which is in the Web3 package. Yeah, so we give it the user profile address with the seeds, so that it knows at which address to initialize it at. And it still gives us an error because we have this inside of the handler. We have this parameter, Twitter handle, which is a string, and we have to pass that one in here. So if we want to have the Twitter username, I don't know, let's just call it Twitter handle. And later we can lock the transaction. And also we want to fetch the data. Oh, one thing we forgot, .rpc, because this actually does the transaction. And we also want to fetch the data of the user profile to make sure that it even exists. So we can, for example, just check check using expect, which is a function from Chai, a testing framework. You can check user profile, account, or let's call it data, dot to equal, then sorry, user profile data dot Twitter handle to equal Twitter handle, which is what we entered up here. So here we get the PDA, so the address of the user profile first. Then we pass in all the data, so the authority, the user profile, and the system program, as well as the Twitter handle. Then we do the transaction, lock the transaction, fetch the data of the account that was initialized. So this is also inside of this program. well, variable, and so accounts. And since user profile is just an account, it also gives us both of our states, so post and user profile. And in this case, user profile dot fetch. You can also do fetch multiple, fetch nullable if you want to check if the account exists at all. So we could check if we could also, instead of checking for the Twitter handle, just do fetch nullable and then check if user profile data is not null. And if it is not null, then it was initialized. Just going to stay with the Twitter handle for now, so we can confirm that our Twitter handle was set correctly. Okay, so this is for the first instruction. Now let's write some tests for the create post one. Here again, we need to get the PDA first. So like this, similar or actually the same as we did it in the first test. So user profile is find program address sync, then the user profile tag and the public key. Because now, as we have already initialized it here, and this does not need to be initialized anymore. It already is initialized. Now we can just use it. So we want to fetch the data as well. So user profile data equals the program.account user profile.fetch. And here the address of the account we want to fetch, which is user profile. And as I said, we already created it here. So here we can just fetch derive the address and use it instantly. So next thing, we want the post. So the PDA of the post, similar to how we did it here. And if you remember it, the seeds for our post were the post tag, then the created posts count and the authority. So we have to just give it the post tag, which is the constant, the authority, which we also have in the program provider.public key. And then we have to fetch the user data and give it the created post count. So here we got the user data. And now if we want to get the post like this, so the posts tag, then the user profile data dot posts created posts count. And since this does not want a number from us but a buffer, we are using our utility function. So it was called int to u16 buffer like this. And the last thing is the provider.public key.toBuffer, the program ID, of course. And there we have our post. Now this has not been initialized yet. So this is also just similar to how we have it with our user. We had it with our user profile. If you enter it into the Explorer, it will just say account does not exist because it has not been initialized so far. Now we can initialize it though using const transaction equals program.methods.createPost. Then .accounts again to give it all the data from the struct. So that means the user profile, the post, authority, and system program. So we got the authority, post, system program, and the user profile like this. So, and now we can just do RPC again to run the transaction. Now what's missing here, we got in the handler, we got the title and the content. So we have to pass that in, title and content like that. And now we can just lock the transaction if we want to, but we don't need to. Yeah, okay, we can. And the post data as well. because we want to check if it exists. Now we can do expect post data.title to equal title, for example, and so that we can confirm, okay, the title was set correctly, then the other data is probably as well fine as well. Now we're halfway through. There are just 2 functions left. So one of them is the like post instruction. So again, async. And what we need this time, Copilot already does a really good job replacing me. So similar to the other functions, the other tests, actually the same. You could it would probably be better to create a helper function in utils or so to get the user profile every time, instead of where we have to pass in the same things. You just have to give it like the public key or so, because we're repeating ourselves here. But
so these ones where we do like this const user profile, this is where we calculate the PDA address for it, right?
Right. So as you can see here, we are giving it the user profile tag and our public key from our user to get the user profile. And that's also what we do here. So in the struct, we have the user profile tag and the authority. So the public key basically. And yeah, that's actually it. So now we want to get the post again, like this. You can actually copy it from the function here. So like this. But now, since we have already created the post with the current count, so let me go from the top to bottom again. All right, we created the user profile and our created post count is at 0. Now we want to create a post and it gets the PDA with the post count being 0. All right, so our address is post tag 0 and our public key. Now, after this is done, the created post count incremented by 1. So the post count is at 1. And if we want to get the post count, the post PDA now, we have to subtract this by 1 because this has incremented after calling the create post function. And if we gave it like this, it would say expected account to already be initialized, because an account with this PDA does not exist, since we incremented it and the post was created with 0 as created post count. So now we can again just call the method like post. This time we don't have any args. We have to pass in the user profile data dot created post count -1 as well, here -1, because we don't want to initialize a new one, but we want to use the last post that we created. So as you can see here, like post, we got this post count here. This is what we're passing, and now the accounts as well. So format this for you. And the authority, the blog post authority, we're going to leave that to the end. The post and the system program. So, and now the blog post authority is the address of the person who created the post. So the authority of the post. Now in this case, this is also my wallet address. So I'm basically liking my own post in this case. But you could also give another person's wallet address here. If he has an account, or if he really has a post, you could give their wallet address and it would not be a security vulnerability. So as I said, in this case, this is our wallet address, but normally you would probably want to fetch the data first, so the post data as well, and then you would just access the post data.authority. But in this case, this is the same as the program provided with public key. Right, then we also lock the transaction. We check the post data after the like. So after the instruction, we fetch the post. Now we expect the likes count to equal 1 because previously it was 0. Oh, we forgot to add the RPC here. Previously it was a 0, now it should be at 1. And the very last function, not unlike post, but delete. Here also pretty similar functions we're calling. Find program address of the user profile, then the user profile data, the created posts, then the post with the seeds, and also this is the last post, so we're adding -1 because we don't want to initialize a new one, we want to use the last post's address. And now we can again call the program. Okay, Copilot did everything for us, so we can go home. But yeah, this is actually it. So we're calling delete post, user profile data, created post -1 because we want to delete the last post. Then we're passing in the PDA of the post, the authority public key, and the system program, just as we have it defined in our struct. And then logging the transaction, fetching the post data, and we're expecting the post data.title not to be equal this. This is wrong. We want to do fetch nullable, right? And we expect the post data to equal null because the post does not exist anymore. And for that reason, it can't find it as well. So we just want it to be null. Okay, so now if everything was done correctly, we hopefully, let me check my balance first. Okay, this is definitely enough. Then we can just run anchor test. And now it again deploys the program. You can also skip that if you don't have any changes to your program itself. As you can see, we have 4 passing tests. This is really satisfying. If you go to the user profile address now, for example, so the last time we checked, it said account does not exist. When we reload it now, it says here we got an account. The address is the one that we found out with the PDA. The program ID, assigned program ID from our smart contract. The allocated data size is the max space we defined in our smart contract. And yeah, this is the rent. This is what we get back when we close our account. Now, here we can also go into these transactions a little bit, or analyzing those transactions in the Explorer. So this is the instruction for creating the user profile. So I will just skip a little bit through this. This is the address here, BP something. As you can see, we added this little bit of soul from our Signa wallet, from our authority, was sent to the newly created account. Because as I said, we have to pay a little bit of Lamports for the space to be taken. And here it just shows us our instruction. So our instruction takes these 3 accounts here. These authority, user profile, and system program. So here this is the system program, the user profile, and the authority. Oh no, so this is the user profile, this is the authority, and this is the system program. And yeah, Here it also shows again new address. This is the user profile that was created from the address, etc. So it's kind of repeating itself. But yeah, here you can also see the program logs. So the instruction was called init user profile, and you can also add custom log messages to your contract, but we didn't do this, do that in this case. And we also have the transactions for the other instructions now, but we can actually look into this one, because here we created the post, but if we check for the new address now, it would probably say account does not exist. But why does it say that? That's because we initialized the user, we created the post, we liked the post, but we deleted the post again. And for that reason, our account does not exist anymore. Now, if we were to run the tests again, you will see that some of them are failing, or at least one of them, I think. So now let's wait a minute. Okay, yeah, so one of them is failing, the initialize user profile function. Why does it do so? It says custom program error. The reason is that our user profile is already initialized, and we can't initialize an account twice. And the reason why create post does not give an error is that we delete the post afterwards. So the test kind of cleans up. Right. And yeah, those are all our tests. We also have a front end with Astro. I will not go deep into that because this will take it will otherwise take too much time. But I can show you a little bit of it. So how it works, as I said, Astro works with these dynamic islands. You have these Astro components and you have framework components, in my case, Svelte. And here, for example, the index route, we have an Astro component. Then we have this postcard, also an Astro component. And then here we have this heart icon, which is, for example, a framework component. And we can always set it here, for example, client. So these framework components have the difference that they have the ability to be interactive, which means that they have JavaScript. And JavaScript is what makes our websites heavy. So that's to reduce that is Astro's main objective. And you can set here when you want the JavaScript to be loaded. So client.visible, for example, loads the JavaScript once the heart icon is visible. And all the components that are only Astro components, they don't have, so they're shipped with 0 JavaScript. But as I said, I won't go much deep into that. What I want to show you though is Solita. Solita is a tool by Metaplex. And this basically, you can generate SDKs for your smart contract, which means you don't have to fight around with creating your own SDK, but instead it just generates all the code for you. You do that by installing the Metaplex Foundation /Solita package, and you just have to create this .solitarc configuration. Here you have the program directory, so the directory of our blog program, the IDL directory, which is in a directory which doesn't exist right now. Then the SDK directory. So the output directory is, I set it to be in the project directly, so here. And we got the binaries, which is on the temp directory, which doesn't exist right now. But I think if we do yarn Solita now, it should generate the, oops, wrong directory. Let me create another terminal. Now yarn solita. It should create right here. We got the temp directory again. So there it gets its IDL and the binary install directory. Also, you have to give it like your program name and your program ID. And now it just takes a while. And once that is done, it outputs this SDK folder. Now I won't do it again because I've already did it. And here, what's cool about that is that you basically have all the functions that you are going to need in this tiny package. So you've got all your accounts. So the post account, for example, as a TypeScript class with all helper functions and the errors you defined, then all the instructions and so on. And later you can use them like this here. So for example, if we want to create a, where are we? Here, get user profile. No, wait, that's not it. Create user profile instruction. So here we can just call this create init user profile instruction. So our instruction was called here init user profile, and then it generates this create init user profile instruction. Then we're passing in all the data, so the same as we did in the tests, but a little bit different from the syntax. The authority, system program, and user profile. Here you just get the PDA as you usually would, and you pass in the Twitter handle. And now we can return the transaction instruction, and then we can just use it to create a transaction. So we can create this transaction object and add the instruction to it, and then we can sign or send the transaction using our wallet adapter. Right, and it's as simple as that.
Just a question. Is it literally just like you create the SDK with Solita and then you can just use that one-to-one in your front end to handle to create the transactions?
Right. So you just have this function, for example, like this create init user profile instruction that you imported from the SDK. Yeah. And like the SDK, this whole thing completely, like this is generated completely. You don't have to write anything here. I just dragged it over and put it in my TypeScript directory. And now I can access these functions, for example. So you can create these instructions, just pass in all the data and add it to your transaction object. And then the send transaction, this is of course from a different package. So in React, you would have your wallet adapter, React wallet adapter. In my case, I did a custom implementation because Astro does not have any wallet packages. I did a solution for that, which uses nanostores, so it's actually compatible with nearly all frameworks. And yeah, so we can just import send transaction from that. So this is basically my package here. From my package, this function, and just pass in the transaction, the connection, and that's it to create the user profile. And when it comes to fetching data, it's also easier. So since you got classes for all your states, you have, for example, this post.from account address, and then you just have to pass in the public key, and you get the post's data. And if you want to like query for arrays of data and not just look for one single account, for example, you can use this GPA builder. So I got this get all user profiles thing, for example. Then you can just do user profile.gpa builder, give it your program ID from your blog program. Then you can filter it by the data size. Since we already know what the data of the user profiles is, it's 61 bytes because we defined it. As you know, we defined it here in the, when we did in user profile. Here 8 plus the max size is 61. So I saved that one as a constant here. And we can just filter by the data size and run this. And then we get all the user profile accounts that were created in with our smart contract. And it's really as simple as that. So you don't really have to, like I remember a few months ago when you always had to, you have to copy over the IDL and then write your own, well, kind of shitty code for your own SDK. But this is really as perfect as it could get. And it makes it really easy. So I really recommend it. If you need to look up the configs and so on how to use it again, the code is all on GitHub. Where was it? On the Super Team Germany GitHub, right? So we got, this is the Glassy Hours website, so the recipe, but Glassy Hour 01, this is what we're currently doing. And here you got all the code from this project, from this workspace. And yeah, so let me also show you the end result that we got here. So I've also made that public. Can send you the link in the chat. And I think the URL is wrong.
Just to answer his question, the recording will be posted on YouTube and it will be added to the Glassy Hours portal as well. So so all the Glassy Hours that we post are going to be recorded and posted on YouTube and then added to the Glassy Hours page.
So here on the recipe, currently it says recording of the talk will be available after the event. Yeah, so the only thing that will change, you just have to commit the URL of the talk later to the markdown of the recipe entry. Exactly, so I wanted to show you the end result. Let me get that out for you quickly.
Might have been in the SDK. I don't know if the program ID was correct. That might be it.
I gave the wrong domain in the GitHub description. Here I said it's Glassy Hours block, but it is this one, Glassy Hours 01. Yeah. So I think I should update that. This can also send it into the chat. So whoever wants can now create their own blog post. I'll just quickly show you how it turned out. So pretty basic UI, nothing super fancy. You just got this. Now currently it's an empty page. We can connect our wallet, backpack, of course. Maybe shrink that a little bit down. Also, it is currently only in DevNet, so make sure you have DevNet funds. Okay, yeah, okay, well now it works. Okay, weird. So here you have this fancy wallet button, which I spent way too much time on. There's your wallet icon, your first few letters, and your balance. You can also change your wallet, and here you can go to your profile, and well, you can create your posts here as well. So currently it says no posts yet. Also, it links my Twitter, which is not really my Twitter though, because it's just a random name. Create post. Now we can just create a lorem ipsum text, for example. a little bit longer. This. And now a few paragraphs like this here. This is of course not the ideal way of creating a blog a blog view, because this is kind of small, but for well, demonstration purposes, I think this is enough for the moment. And now here write our content, and this is also like the maximum is at 3,000 letters, and we will also be limited at that, so we can't go further if it is over the limit. Now we can submit this, and as you can see, or as you will see in a moment, hopefully, oh, our backpack crashed again. Okay, now we try it again.
Oh, I have a post.
Submit. Oh, did it work? Okay.
Yeah.
I think it's because of backpack. A few times like backpack crashes here and there for me. Let me try it with Glow again.
Yeah, Arc and backpack don't play well together nowadays.
Oh, okay.
Both players where it's at.
Oh, there we go. Oh, it's the wrong URL. So that's the URL. No, that's not the URL. Glassy Hours 1. I think that's the URL. Yeah. Now let me use Glow.
That's
so yeah, so as you can see here, you have the Twitter, and you can also press like, or I can press like. You can also, I think.
Oh yeah,
there's also no limit. Yeah. So and I hope I can create a post as well now. Okay, I do not get wallet pop-up somehow, but technically it should work. I'm not sure if it's because of Arc, but yeah. It works for you. It works on your machine.
Demos that will never go well.
Okay. Oh yeah. Okay. Now I'm getting 100 wallet pop-ups. Yeah. Okay. Now it works. So I got a post as well, and you should be able to like them as well. And if it's your own post, there's also a delete post button. Yeah, but that's only visible for yourself.
Liking your
Is it?
Okay,
and that's our simple blog application. Really minimal. One thing I learned from this myself was like that was my first time using Astro for a Web3 application. And in my opinion, if you are using an application like this, or if you're creating an application like this, you're better off with a framework that is a single page, to create single page applications, because as you can see, when I, for example, navigate to this post here, it's kind of, well, not persisting the state and things like that. So of course we got really, really fast website, but still it's probably a cleaner experience if you have a bigger application to use a framework like Next.js or Nuxt. Yeah. And again, so if you want to check out the source code, or if you want to commit anything, check out GitHub. I can send you the link again. The Superteam Germany, and then Glassy Hour 01.
Yeah. All right.
So yeah.
Right. Yeah. So all of these, everything is going to be on the Glassy Hours platform, just going live. It's already live. So yeah, cool.
Awesome.
Cool.
Great.
Thank you. I guess this was it. Very good first hour, first Glassy Hour. Yeah, we'll put up the recording and then it's going to be available and then they'll post about it once it's done.
Awesome.
Cool.
Great.
All right.
All right then.
Bye, guys.
Bye. Have a great
See ya.
Saturday. Yeah. All right. Ciao.
Ciao.